Hi, my name is Kaylee Burt, and today in this lab I'll be examining the motion of a spring mass system. So the purpose was to examine and predict the motion of an oscillating object, compare the predicted motion and the observed motion, and then plot the computed energy changes from the model. The observed motion is from the program tracker, and the predicted motion was calculated from GlowScript. And then a preview of the result, the change in total energy is 0, and then the predicted and observed motions are similar. The physics principles I used for this lab, Newton's second law of the momentum principle, specifically the momentum principle, velocity update, and position update. And then other principles were the energy principle, and I used the total change in energy of the system is equal to the work done on the system by the surroundings, plus the exchange of thermal energy between systems and surroundings, and then the change in kinetic energy, change in spring potential energy, change in gravitational potential energy, and then S spring. Initial conditions and the system and surroundings. The initial conditions time was 0. The delta t in tracker was 0.095 seconds between each time frame. The initial position, the initial velocity was 0. The mass, the spring constant, and then the initial length of the spring, the relaxed length. And then the system was mass, spring, and earth, and then the surroundings was nothing. So then I uploaded the video that was given for this lab to tracker, and I moved the axis to make sure to set the origin to the fixed point of the spring, and then I used the track tool to track the change in position during each time interval, delta t, and then these are the x and y position graphs versus time from tracker, and a kind of a little preview of the result for the versus predicted graphs that come later. Okay, glow skip crowd part 1. I set the time to the initial conditions and left delta t, and then I set the mass, position, velocity, gravity, the spring constant, and the initial position of the spring to match the initial conditions mentioned earlier. And then I used the ball position to update S, the spring length, and then change lines 93 to 96, the bottom here, using the energy principle to compute kinetic energy, gravitational potential energy, the spring potential energy, and then the total energy. And then here's the part 2 of the closed loop code. I changed the time to the time of my last iteration, and then I defined the initial energies that were calculated earlier, and then defined F grav and F spring using the net force formulas, and implemented Newton's second law, the velocity and position update formulas mentioned earlier. And then once again, I used the new position to update the spring, and computed down here the new kinetic, gravitational potential, and spring potential energies, and then use the initial energies to find the changes in all the energy types. And then this is what it looks like when I run the code. It's going pretty slow, but you can see the change in energy versus time graph start to form, and then the x position versus time and the y position versus time. So here are the x and y position versus time graphs. The blue is from the observed in tracker, and then the red is from the predicted graphs in GlowScript. You can see both the models are fairly accurate, but the y position versus time observed graph is a little less accurate, probably from possible sources of error like not accounting for drag and other forces in the video. And then here's the resulting change in energy versus time graph from GlowScript. So for the colors, the blue is the change in kinetic energy, the red is the change in gravitational potential energy, the green is the change in spring potential energy, and then the orange is the change in total energy. And as you can see, the orange line is permanently on the x-axis, so y equals 0, which means the total energy remains 0, and then energy is transferred between the 3 types of energies listed here, and no energy leaves the system. So for possible sources of error, first, human error from inconsistent markings in tracker that don't exactly align perfectly with the motion of the object and the center of the object. And then the predicted model from GlowScript doesn't account for forces, like I said, besides spring force and gravity, like the drag force in the video from tracker. And then also the initial position might not be 100% accurate because of the markings in tracker, and then attempting to start the video at the correct frame when the object first starts moving. So for what does it mean, it asks for the model, is the energy principle satisfied? And I said, yeah, it is satisfied, because when the system is the earth mass in the spring, there's no work from the surroundings, and there's no change in the thermal energy. So the change in total energy is 0, and that is clear by the horizontal orange line at y equals 0. Using the other, what does it mean, is using the data you obtained in tracker, make two separate estimates of oscillation periods. So the period of oscillation from the X position is 1.63 seconds, and then from the Y calculated 1.564 seconds. The difference between the two is about 0.066 seconds, and then the difference could be, once again, because of the inaccuracy in tracker with outside forces. Thank you.